Hi everybody. I wanted to do a quick weather update for you, maybe about 5 minutes or so, and just go over the plans for today too, the things that I'd like you to work on for the double period today. But let's take a look at the weather first. So here we have the National Weather Service, the NOAA forecast. We've looked at this many times before. And if we take a look at the weather for the next few days, it's really kind of an interesting setup. We're looking at, first of all, some nice high temperatures. Today we're looking at a high of 68 degrees, very spring-like. Some clouds though, partly sunny, might be a little bit more sunshine in the afternoon than right now. But cloudy but warm. As we move into Friday, even warmer, 71 degrees. With some showers and some patchy fog though. So maybe not clear skies, but warm weather. This all changes as we get into the weekend and the temperatures start to drop. Here we have a high of 57, Saturday night low of 30. Then we get into Sunday, windy day, 41 degrees Fahrenheit for a high, and then a low of only 26. Now, for people like Michael, there is the possibility of a little bit of snow, chance of snow turning to rain on Monday. We're seeing this change in weather pattern because of the direction of the airflow, where we have the warmer temperatures of today and Friday. The airflow is coming from the south and southwest, so we're having warmer air from the south moving up into our area. Then the wind changes direction, and we'll talk about this more probably next week. But when the wind changes direction, it's going to bring the air with it from where it was coming from. And now we have a flow of air coming out of the north, and that's causing the temperatures to drop. Now, if we take a look at the Weather Underground website, this is the information essentially off of the roof, and the weather station on the roof. The little monitor near my computer on the desk should have the same information as this, coming right off of the rooftop weather station. But we can see a chance of a thunderstorm for Friday, and then we have a little bit of snow. But same thing that we've been dealing with all winter. Less than an inch, probably not really any accumulation. If we do see snow, it'll look nice, it might be pretty, but it's not really going to accumulate to much of anything. I was just taking a look at these arrows down here. These arrows indicate wind direction, and here we can see south-southwest. It says from southwest, south-southwest. So this means that the wind is coming from the south and southwest, warmer air. And then when we get to here, now the wind is shifted out of the northwest, if you can see where the cursor is. These arrows indicate the direction the wind is coming from. That's something we talked about before. It's not the direction the wind is going, it's the direction the wind is coming from. So now the wind is coming out of the northwest, and we can see the air temperature has dropped. And then, later in the week it changes more. But for the next few days anyway, we can see the air coming up out of the south-southwest, bringing warm air with it. We'll see nice warm temperatures. And then when we get the passage of the frontal system right here with the rain, then we get, just refreshed, then we get to the colder temperatures as we get wind coming out of the northwest. Okay, so anyway, I just wanted to show you that to you. Now, as far as the plan for today goes, there's a few different things I'd like you to do. One is I pulled up the weather map for today, and I put that into a Google form. And what I'd like you to do is take a look at that weather map and try to, on your own, write a description of the weather events for today, kind of like we would often do at the beginning of class. But I think that at this point you can do that somewhat on your own. It doesn't have to be perfect, but just do the best you can. You can discuss it. You'll probably come up with more than you would by yourself if you discuss it a little bit. I also posted 2 videos about humidity, relative humidity, and dew point. And those are very important videos. Understanding dew point and relative humidity is probably one of the more complicated concepts in this unit, but it's very important. So as you watch those videos, I'd like you to have your class notes out and follow along as you watch the video. If you are having a hard time understanding some of the concepts, go backwards in the video, of course, watch them again. And if you're really stuck, always you can email me or post a question through Google Classroom. But those are important videos, difficult concepts. They're not easy. Some of the trickier concepts of this unit, dew point and relative humidity, and truly understanding how they work. But anyway, I'd like you to watch those videos. I'd like you to do the weather map first, then watch the videos. Then after that, I'd like you to get back to working on that weather patterns lab that you started in your lab book. And what we'll do is I'll take a look at that with you under the projector and just show you a few things so that you can kind of do it on your own a little bit better. So I'm going to pause the video and get my lab book out, and then we can look at it together really quickly, and then you can get to work on that once you've done the other things. Okay, so I'll be right back. Okay, so we're back. I've got my lab book here, and I just wanted to go over a few things. It's been a little time since we've looked at this last. But we have the vocabulary, which of course you can do pretty easily with the computer. So you could use the Chromebook to work on vocabulary. Okay, the temperature pattern section, the temperature pattern map, I think that one should be pretty straightforward. I really don't think you're going to have issue with that. Just remember, temperature is the one on the upper left. Okay, the one on the upper right is the coded air pressures, but that's not what it's asking you to do here. That's the next map. So here you just plot your isotherms and then answer the questions on the next page. I think that part's pretty straightforward. Okay, then we get to barometric pressure, and I know that many of you started this. Remember, it's important to use pencil on this too. Throughout this lab, it's very easy to make mistakes, and you really need to use pencil on this one. I'm usually pretty flexible about that, but this one really needs to be in pencil. Here we've got our air pressures, and remember, you're either going to put a 9 or a 10 in front, and then move the decimal. And my advice for deciding if it's the 9 or the 10, remember, is whichever brings you closer to 1,000 millibars. Anyway, you'll need to go ahead and decode these and then plot the air pressure isobar lines. And on procedure B up here, and I know some of you have done this already, I'm not sure if everybody has, but it says use a 4 millibar interval. So that's going to be essentially your contour interval or your isobar interval starting at 1,000 millibars. And then once you plot it, it asks you to label the centers of your high and your low air pressures. And I think you can find that. It would be not really that different than an elevation map, finding a hilltop and finding a low area. Same concept. Okay, then there's some questions, some gradient calculations, should be straightforward. Now over here, this is surface wind patterns, and remember, these circles represent weather stations that are actually on the ground in different locations in different cities. And this is just a small portion of the weather stations that are out there. Of course, there's thousands across the country, and this is just simplifying it a little bit. On these station models, they're called, these little circles and the symbols, the shaft or line sticking out of them represents wind direction. And in this case, it's the direction where the wind is coming from. So in Winnipeg, the wind is coming from the northwest. Now, in the instructions under Procedure C, it says, at each station model, extend the shaft of the wind arrow through the station model and draw the head of the arrow to show the direction the wind is blowing. All they're asking you to do is to extend this line like that and put an arrowhead on it. Okay, and you're being asked to do that for each one of these station models. And that'll help you see the overall pattern of wind movement for this map on this day. Okay, then it asks you to draw larger arrows to show the general pattern of airflow. So what that means is you're going to put arrows through all of the shafts on your station model. But then what it's asking you to do is to draw some larger arrows. And I'm not going to give this away, but, you know, something like maybe that, you know, or whatever, on the map to just show the direction that most of the air is, most of the wind is moving. So you're going to just draw some larger arrows on the map somewhere to show the overall pattern, is what it's asking you to do over there. Okay, then we get to precipitation patterns on map D. Now for this one, it's really been simplified some. Usually on a weather map, if it's raining, the station model is going to have a symbol that's going to have like a little dot, and it explains that under Procedure D. But to simplify things and just make it a little easier for students, on some of the station models in the center, there's an R, which stands for rain. If it doesn't have the R, it means it's not raining in that location. We talked about once, too, the shading on the circles, and if you remember, those represent cloud cover. So in Minneapolis, it's 50% cloud cover. In a city like Buffalo, 100% cloud cover. And then here, even though the circle is clear, it's still probably 100% cloud cover is raining, but it's not shaded in because the R is there, and if it were shaded in, you wouldn't be able to see the R. So we have rain here, and it's basically asking you to just draw like an ISO line to enclose the areas of rain. So you're basically just going to draw a circle around all of your R's, wherever it's raining, and then lightly shade in the area where precipitation is occurring. Now, under Procedure D, number 3, over here, it says to label continental, polar, and maritime tropical air. Now, this is something we haven't talked about yet, and we will when we get to it. But I think that you might be able to kind of think it through a little bit. Continental means that the air formed over land and is dry. Polar means that the air is cold and came out of the north somewhere, maybe Canada, maybe the Dakotas or Minnesota, somewhere like that. Maritime tropical means essentially the opposite. This is air that formed over the ocean. It's maritime, meaning water, and then tropical. Now, sometimes students get a little hung up on this word tropical. Don't think rainforest. That's not really what it means. In this context, tropical just means it's hot. So tropical air could be hot and humid like a rainforest, but tropical air could be really dry like desert air. So it's just kind of a strange meaning of the word. You know, we always think tropical rainforest, but in this case, in this context, it just means hot air. But it doesn't give you any indication about humidity. That comes from either the maritime or the continental part of the term. So anyway, I think you can probably figure that out. We'll see how that goes. So anyway, that's it for map D. Now map E, the synoptic weather map, and we talked about this last time when we worked on this. Synoptic basically comes from the word synopsis, which I was honestly a little surprised most of you didn't seem to know synopsis. It just means summary. So on this map, now you're going to put it all together, and you're basically going to combine maps A through D and put them onto one map that shows all of this information at one time, and you've essentially created the weather maps that we've been looking at the start of class. A synoptic weather map of the weather for the time and date. Now for Procedure E, I think you can answer a lot of these things, but one thing we haven't really talked about yet are fronts, and it's asking you to draw in cold and warm front locations with proper symbols. That's something we haven't done quite yet, and I think I'll save that for tomorrow. But I think that this is enough probably to keep you busy, so we'll work on finishing that up next time. So anyway, a few different things to work on. I'd like you to work on summarizing the weather for the daily weather map. Okay, then the videos with the class notes, and then work on the remaining part of the lab for today. So good luck, and again, feel free to email me or post a question on Google Classroom and if you have any problems at all. Good luck.